So here you can see we were able to make the query, and it's returning us 4 document. Basics. We are going to learn about how to use LangChain with the latest model GPT-5. We are going to run this tutorial on GPT-5, but if you want to follow with free and open source model, you can try the Grok, which is exactly same. You just in the base URL you'll have to specify the Grok API's base URL. Rest of the things will be completely same. So let's start with the absolute basics of LangChain. We'll first learn how can we load a model and invoke it. So let's create a folder. Let's make it chapter 1, or let's make it module 1, and let's make a file basics. So now first thing first, we'll need to do the installation. So let's go to LangChain OpenAI, and let's copy this command because we want this. So let's install it with the help of UV. So if you don't know UV, there is a video in the channel like how can you use UV. We will be using the UV extensively. So now let's start our hello world of the LangChain. So from LangChain OpenAI, let's import Azure. I will be using Azure Chat OpenAI because I have deployed my own GPT instance, which I will be using. For that tutorial will also come how can you also deploy your own GPT private instance. So let's go and this is the model that we do, and in the model we'll specify GPT-5 mini. This is how you create a model client. Now let's see how we can invoke this. So let's call model.invoke, and let's ask this something. What is the LangChain? CHAIN. And let's also print response.content because this is what we want. Now let's run this code. Module 1 basics. Okay, so this the basic error. It was not able to discover my credential. So for that we'll need to load the environment variable from .env, load.env, and then invoke this. So this should fix that error, and hopefully we'll get the response from my Azure. Perfect. We were able to connect to our model, and the model has also responded. LangChain is a developer framework building applications. Key concepts: why use LangChain, example, JavaScript example. So perfect. this is what we wanted, and this is the basic. Like, you'll have to make sure that you are calling the model. This is the invocation. Now let's learn how to make this. Is not the way I have given the message, it works, but let's see how LangChains want us to give the input. So this is a human message. So now let's import from LangChain core dot messages, import human message. Now all we have to do, we'll need to prepare our message. Let's define prompt, and it will be an array list of human message. For now we'll just pass human message. What is the let's ask same question. And what we will do, we'll remove this line from here, and we'll pass, this time we'll pass the prompt, and rest of the things are same. So we'll run the code and see. Perfect, it worked as previously as same way. And this is how the human message, like this is our human message. Same way there are AI messages, and then there are other message type as well. So now let's look at the system message. So again, from LangChain core messages, let's import system messages. So once you do that, we can define a system message as message. So let's define system message. Here we can right now define any message, like any system message. Like if you want to make a chatbot for any particular a use case, so for that domain you can make it as an expert or a peer, something like that. So that you can do here. Let for example, we can write you are an expert on radiology that respond to the user query with correct information. So this is going to be the behavior of the model itself. Now what I'll tell you, let's separate our human message from prompt. So let's make it human message, and then we are going to, in sequence, we are going to pass these information to our model. So now we'll prepare a list, or maybe I can do it here, message list. So first we'll pass the system message, and then human message, and then we'll invoke our message list. So this should pretty much give us an idea. And let's ask this, what is X-ray scan? Let's see if it answers our question. All right, so we have our answer. An X-ray is a medical image test that use small amount of ionized radiation to create a picture of the inside of the body. It relies on the fact that has different tissue absorb X-ray to a different degree. Yeah, so this is great. This is the in context generation that we wanted from our model. Now that you have learned the structure of human message system message, now we will learn about the prompt template. So we'll cover that in the next video. Thank you. Prompt models in LangChain. We'll learn about the prompt templates and how can we invoke them with our models. Also, we will learn about the variables that we can place inside our prompt templates. So for that, let's create a new file. We'll name it prompt py, and let's copy the code from previous session. Most of the lecture we will be needing this much code always, but what it is doing, it is importing the LangChain Azure AI chat OpenAI. If you are using the OpenAI directly from Azure, then there is called chat OpenAI that you can directly use. For my case, I have the Azure subscription, so I will be using the same one. Now we'll learn about the prompt and models. So let's prepare a prompt template. So in previous video, if you remember, we have imported the human message system message from code. For now, we don't need them because we will be learning the prompt template. So let's import the LangChain code prompts and import prompt template. Now let's prepare a template. Prompt template, prompt template. Now for here, you can define a docstring or a string. So let's define a use case, and let me write a system prompt and a context question same. So this is the idea, like there will be a system prompt and there will be a context that we can replace when we are invoking the model, and we'll after that we'll set the question. So you so let's answer the question based on the context only. So let's enforce the condition that the model should not go outside the context. If the question cannot be answered using the information answer with I don't know. Now let's give context, and this is how you define what you want to place here. So I want context to be placed here, and then after that the question, and we can say type your answer here. So after that model will generate the answer. So this is what we have done. We have prepared our template. Now prepare the prompt. Is equals to template dot. Now we are invoking. So see, we are invoking our template first. And the template we have to define it as a dictionary right now because we want to pass the context. We have defined two variables and then the question. So let's give the context. Let's say the current Prime Minister of India is Modi, and we'll pass this as a context. Now let's prepare a question. So who was the Prime of India in 2010? Let's give the information of which year it is. 5. It should, although the model knows it from their training data, but we want it to enforce that I don't know because it is outside the context. So let's see, it would be very interesting to see if it follows our uh, the the context that we have provided. Let's print the response.content. So UV run module prompt template. So it says I don't know. Now if I'll ask this question as in 2025, let's see, Modi. So now you see the model is responding as per our context. This is what makes it very important uh, to control the model behavior. So yeah, so this is how you do the prompt template. Now let's learn about the chat prompt templates. So this is prompt templates. Now let's import from LangChain core.prompts. Let's import chat prompt template and let's comment out these. Now let's prepare our template again. This time it will be a chat prompt template, and from messages I'll start with the basic one. Then we can also put the human message or AI message here as well, but let me also give you the basic way of doing it with the help of normal Python objects. So inside our left, let's define a tuple, and this tuple will contain the system. This is going to be a system message, and we'll copy paste same thing. Let's keep the uh, system message separate, and then here what we are doing, we are breaking up the uh, way of conversation. So this goes first. After that, we'll take the human, and human will give the context. So after that, human will again give the context. This time, the question. Question. And will now let's copy this code. Let's copy the whole, because the invocation will be same. We'll just uncomment this. This is context question, and now we can pass this into the model. This model dot invoke prompt. See if it should still work. Yeah, same thing. The ways are different. Previously, we were defining all of this in a string. Now it has been broken apart in terms of uh, the system prompt, then human message, then again human message, and so that's how you prepare the prompt template. And in our next chapter, we are going to learn about how can you retrieve a structured response from a model with uh, so that we can ensure the model output will always follow a particular structure that we want. Thank you. Can we get the structured response from our LLMs? So let's copy few codes from the previous lesson. All it is doing, it is importing Azure Chat OpenAI and loading the environment variables. And we will be using GPT-5 Mini. So how can you make sure that you will get a structured response? So for that, we'll need to install a dependency which is called Pydantic. So once Pydantic is installed, let's go and import the base model. And we will define a schema based on what's like what we actually want from our model. So let's define so this is how it is done. You create a class that will inherit the base model. So let's define the location info and base model. So we'll make a chatbot that that once we give the location, it will tell us about the uh, weather and place to visit. Let's see. So this is going to take it will take the information and give location. This will be str, and then we'll use docstring and we'll get the location, the user from the users query, and we'll also it would be better to define docstring. It will be passed information. Now let's define justification. justification, give the why you think user is asking about location. And let's now, since we have our LLM ready, so usually for structured response, we want the temperature to be 0. And to get the structured response, we'll have to make our model as structured LLM. Let's make it LLM. It is model dot with structured output, and we want the location info. This is going to be the schema, and let's collect the response. Structured LLM invoke, and I live in Delhi. I want to visit Mumbai. Help me plan the journey. So let's also make a plan. This is going to be list of STRs. So define the plan for the user. And let's print the response. So let's run UV module 1 structured. Yeah, perfect. So we have the information as location, Delhi to Mumbai. Justification, user is asking for help planning from Delhi to Mumbai. I'll give you a clear transport option. Here is the plan, step 1. So because it is a pydantic schema, so we can enforce uh, and we will get back some help from our ID, hopefully. So let's parse this output. Let's print this. I'm just doing some formatting. Let's run this again. So if it model is not able to parse the output, then we will, now you can see we were able to parse this information. See Mumbai traveling from Delhi, asked to visit Delhi, plans, and here is the plan. Perfect. This is what we wanted. There is another output parser apart from the Pydantic, there is a common CSV output parser, and let me just show you like how it works. I'll comment out this code. It is useful sometimes. So let's import from LangChain core dot output parser, import comma separated output parser. So let's prepare our parser and comma separated output parser. So let's prepare a simple list as the CSV parser. Let's see value 1 comma 2 value 3, and then print the response. So what I'm trying to tell you that, I mean, there are multiple other parsers as also available that you can check out from the implementation. There is another JSON output parser, simple JSON output parser, list output parser. We had just explored one of the ways, and like you can control click on the module. It's command click for Mac, control click for Windows, and then you can all look like what are the things available. I just showed you one of an example, uh, like with Pydantic and the CSV parser. Well, most of the time you won't be needing it if you are using the for I mean structured output in as a JSON. We usually want it, so you can use Pydantic models to get a structured output, and it really helps in creating chains, more complex chain that we are going to learn about in the upcoming session. In the upcoming session, we'll learn about chains. So thank you. In chains, we will learn about various way of writing chain, the imperative method as well, and the LangChain expression language method as well. So before that, I wanted to give one concept of methods, like how can you make a invoke of a model as a batch or as a stream. So this is an important thing that we missed in the basics lecture. So let's first learn that, and then then the concept of chain will become very clear. So from LangChain OpenAI, import Azure. If you are using Grok, you can import the respective client. So let's make an LLM. So also I need .env, right? Load. Let's load our .envs. This will load all environment. Let's make our LLM client Azure Chat OpenAI, and we will use GPT-5 mini. GPT-5 mini, and let's call the first one, you know it, using LLM dot invoke. By now you know how to use it. Now if you want to make multiple invocation as a batch, this is what you have to use. So completions is equals to model LLM dot batch, and here you need to pass the list. So let me ask what is chain, and next in batch I'll ask what is Python, and let's print this out. and let's see what we get. Module 1 methods. You should see answers for both of them. Alright, so if you see the response here, there is one AI message and then there should be another one for the next question. There you go. This is the another AI message that we get back, and the content is LangChain is open source, Python is a high level general purpose language. If you see, there are other things as well that we get, like reasoning token, rejected token, prompt detail tokens. We are going to learn more about them in the upcoming lecture. Since GPT-5 is a reasoning model, so it takes some of the reasoning and then it gives back the output. So this is perfect. Now, if you see, whenever we are calling our model, we are getting response back completely when we complete when the completion is done. So what if I want to get the output as it gets generated? So for that, there is called from tokens in LLM dot stream. Sorry, it is for stream, and then your question would be, hi, how are you? And then you can, it is an iterable, so you can print the token as we collect them. So this time we should see the response as we get. So if you see the content, I am just a virtual assistant, so I don't have feeling. And you'll see the other things like run ID and finish token. Reason stop model is this. So these are the information that we get. If you just want the content, then you can also just see the model output as well. Just put dot content. Now with this done, we will learn about the chains. So let's bring this much code, which is bringing the LLM and then bring the LLM, and this time we are going to use the previous concepts of from LangChain. Let's import from LangChain core dot messages, import human message, and then system message, AI message, and we'll also bring the chat prompt template from LangChain core dot prompts, import chat prompt template, and let's learn the imperative way of creating chains first, and then we are going to also learn the LangChain expression language way, which is more convenient. But learning imperative way is also useful because then you'll have more control over your chains. So first of all, we have defined our LLM. Let's also define the template. Is the chat prompt template dot from messages, and let's put the system message, let's say you are an full assistant, and then we'll put human message, which is going to be question, and let's make it a variable. We'll pass that value from while asking the question. So now what we want to combine them in a function with at the rate. There is a decorator from LangChain core runnable. Let's import it. Runnable chain. So let's define our chain chatbot. What we will do, we are going to combine this prompt template with the model. So let's prepare a prompt. So right now it is a template. Now once we add the question, it will become the prompt. It is going to be template dot invoke with the value, and let's return LLM dot invoke and the prompt. So now let's see the response from the chatbot. Chatbot dot invoke, and here we'll pass the question. What is the biggest our solar system? Let's ask this question. Let's print this dot content. UV run module chain oh, human message. All right, we okay. So we cannot pass it as it, this is using this way. So what we can do, we have also learned the other way. So it is a human and then question, then it will work. Yeah, so it picks the question. Jupiter is the largest planet in the solar system. And what I was trying to do, we'll learn in the upcoming session how to like use messages to inject the uh, parameterable values. So for now, this is how it will replace question here when we do invoke. Previously, I used directly the human message, which is not the correct way of doing it. This is the correct way. Sorry for that. And now, once you understand the imperative way, you then you can also understand how to. This is a uh, invocation. Now, how can we stream this invoke? So we have just learned that in the previous just 5 minutes ago, like to stream the token because we got the output once everything is done. So let's stream the output from here. Once our prompt is ready, we can do for token in LLM dot stream. Then you can pass your prompt, and from there you will yield it. So since you cannot return it, you will yield it. And so same way when you are calling the model, so let's how you can see the response. For parts in chatbot dot stream. So look, the because we have added this decorator, we are getting like these methods already implemented for us. Let's take it, same question, and this time we should see print part and yeah. So as it was streaming, let's only put the content. Then it will be more clear. That's how you stream the response. See, it's coming, and that's how you must have seen in the chat. Uh, I mean, chat models like OpenAI. There you see the tokens are getting streamed. So that's how it is done. And so this is the way. How now we'll learn how we can do it asynchronously. So this is a synchronous way. So now for that, what we have to do, we have to await it, and instead of yielding it, uh, we are going to make a asynchronous invocation. So let me comment that part and let's await it. And it is a invoke, which means it is an asynchronous invocation, and this function has to be async. Perfect. Now we can await until the output is coming. Mod it is LLM dot a invoke and then your prompt. So let's define an async main function and return await chatbot dot a asynchronous invocation, and let's ask this same question. Now let's call if render name equals to let's import async IO, and we will make a asynchronous run dot run See, this is how you make an asynchronous calling, and you just make sure to await it when you are making an asynchronous calling. Now let's learn the declarative way of doing the same thing that we have been doing, like chaining the prompt and the model. So let me comment it out. So this one is the handy one. Let's combine with the OR operator, this pipe operator. So see, we are making chat, same chat bot is what? First of all, it takes the template, then it passes it to next is the LLM, and this is the most easiest way of doing that. So once you do that, you can reuse the same code that we have printed here, and it should work without an error. Let me see if everything is right. Yep. See, you are getting the same answer. This 90% of the time we will be doing this thing, but there are some requirement where before the invocation of the model and prompt, we want to manipulate the input from our own end logically. In those cases, we will prefer to use the imperative one. And we have learned, since we have learned all of the ways like asynchronous, synchronous way, a streaming way of making chains. So that clears up all of your basic fundamentals of how can you use the LangChain effectively. So from this completes the module 1. Next module we are going to learn the various data fetching loading techniques, and thank you for watching this session. Bye. About the retrieval augmentation generation, short form RAG. So this we will going to learn about end to end of it. So the first step of making any RAG system is to load the document itself. It could be from anywhere, and we are going to see various methods how we can load our data. So I have taken a PDF, a text file, and a markdown file, and let's try to read them and see using the LangChain how can we do the loading of a file. So for that you'll need to add the LangChain community. So once this package is installed, so let's from LangChain community dot document loader, let's import. Let's first load the text loader. This is the class we have imported, loader dot text loader, and then you need to specify the path. So I have this text file. Let's get the relative path of it, and we have to specify the encoding is the UTF-8, and then that's how you loader dot docs dot load, and let's print the document. Now let's run it. Module 2 rack loader. There you can see we have loaded a document. So good thing about this, it creates the metadata of the document itself. See, metadata, source, the file of path, and then the page content will be very convenient for us when we are making the RAG, like when we are inserting the document. So this structure will become very important. So now let's uh, try to get our document from a URL. So for that, make sure that you have beautiful soup dependency installed. Let me do it. Let's also do bs4. So it will install beautiful soup 4, and now we can import web web-based loader, and let's comment them out. So same thing, loader, web-based loader. Here you need to specify the URL. So let's get the document of, I'm just making an example. You can make any URL, you can pass any URL here. Make sure that if they do not detect us as a bot, then you will be able to get the document. Load. Let's print what we have loaded. Perfect. See, now the metadata source, we are getting the title and its language, and this is the page content. See, uh, we are getting multiple informations. Now, once you learn about the uh, loader, then one of more important is the PDF loaders. So let's also learn them. So there is a class which is PyPDF loader, and same thing again, the PyPDF loader, and we'll need to specify path to a PDF file. Let's copy the path, and rest of the things are exactly same. Okay, so we need to install PyPDF, no problem. Perfect. So what we get, uh, document producer, creator, creation date, title, author, metadata, modification date, source, total pages, page 0 content. In a very structured way, we have read that LangChain paper that we want, because these informations will be very handy when you are creating any RAG system. So now we just have loaded our document. We cannot put an entire document to an embedding model. So for that, we'll need to learn about the text splitting. So in next lecture, we are going to learn how we can split the loaded text. Thank you. We have learned about how can we load the document as a text for our model with their metadata and all. Now let's learn about how can we split those text recursively. So for that, we are going to import one class from LangChain text splitter, import recursive text splitter, and from LangChain community dot document import text loader. Let's use the text example. So again, it is going to be text loader. Then you pass the path. I have a file here. Let's use it. And let's define the encoding is UTF-8 loader dot. And then now let's create our splitter. So it is recursive text splitter. We need to define the chunks of split that we are going to do. So it is chunk size let's give thousands, and then chunk how much overlap we want between the chunks. It is 200. You can define as per your requirement. So let's make our docs. It is going to be splitter dot split documents, and then splitted docs, and let's print the splitted documents. This is the basic way of doing the splitting. See, this document has been splitted as one because the text was very small. So let's make it and smaller chunks. This was really big chunks. Now it has been splitted up in the smaller chunk, as you can see. Will be what we can do. Let's for let's print this 50 times. Then we will print the doc. See our splitted text. Now these are the chunks. Now let's see how can you, because we know this is in generic text, there can be chances where you have to import based on certain languages you want to make split. So there is a language class. Now let's create a because this document does not create any code. So let's do one thing. Let's prepare a Python code. So it is def hello. I'm just preparing one simple documentation that prints the hello world. And let's also add comments. Sample function Now, when we are doing the splitting, this time we are going to call from language, and here we need to specify which language. So language is language dot, this is Python, and let's make a chunk very small. Let's make overlapping 0. So let's see now how the splitting will be done. One second, because we have loaded again the text one. So when we are calling the splitter, we need to pass the code as a list. Python code. Let's see. Okay, so recursive character text splitter. This is the correct class. The language. From languages. So we should not call the split document. In this case, we'll call create document. Then we will be able to get our code as the documents with the chunk size of 10 characters. Here you can see. So we were actually calling the wrong method earlier. So that's why there's the error. So once this is done, let's also learn how can, because most of the documents we will be storing them as a markdown. So let's also learn the markdown way, just as simple the Python code. Let's make a markdown. I have a markdown example. Let's copy it, and we have pasted it, and let's markdown, and here we have to change it to markdown. Let's increase the chunks. Let's make them 100, and this time we are calling the correct create documents class, and this is the markdown text. Let's because we are creating the document, I'll also tell you how you can uh, specify the source. So let's because I have taken this from the LangChain.com, so let me put the source as this. Should see we have created our document from markdown text. So these are the documents and the metadata source it has also taken it. So this will be very useful if you are loading your own data and you wanted to make sure to specify the page number and all in the source. You can do that. And this is how you do the splitting. In the next lecture, we are going to learn about the embedding. How can you create embedding from these loaded text? Thank you. About the embeddings now, we have learned ways how to load the document and how to split them. Now let's learn how can we convert those chunks into embedding, because models only process embeddings only. So to do that, you need to uh, have a model that can take your input text and convert them into embeddings, the vector representation. So let me show you how you can do that. So from LangChain OpenAI, import OpenAI embeddings, and I will be using the Azure. Normally, you can use OpenAI's, but since I'm using my Azure model, so I'm using Azure OpenAI. So for that, I have to .env import node.env, and so that it loads all the credential. And let's create our model client, Azure Open Embedding. The model that we are going to use is this text embedding ADA 002. So we need to specify the model name, and then let's create the embedding, embed documents. So you can pass your document. We can write any text. It could be loaded from anywhere. So thanks for watching. Yeah, so let's say these are our document chunks, and now once we pass them to embed the document, then we can print the embeddings that was getting generated. So this is how you make the embedding from the documents. Yeah, sorry for that. Yeah, here you can see we got the vector representation of the text that we have written, and let's see the length of the embedding that got generated. Let's take one of the document. So it is 1536, the length of this embedding. So this is just a toy example. Now we are going to take a better example where we are going to load this document. Let's load this text file and then create embedding from there. So what we can do, we can copy some part of the code uh, from our previous code. Let's bring them here. So LangChain text splitter, load document, LangChain doc, and then we will call. Let's first bring this up here. So now what we can do, let's recursively split this document. Recursive character splitter. Chunk size is, let's keep 200. I think 200 would be enough. Then we can do chunk overlap. Let's make it 20 characters. Let them overlap, and then let's collect the chunks from our splitter that we have created just now. Dot split document, and here we can pass the docs. Now on our embedding document, what we can do, we can pass the chunks instead of these example chunk chun chunks dot page content for chunk. Actually, because it's an array, so we'll have to iterate it. For chunks in chunk, we'll only pass the page dot content. And once this is done, let's actually print all of the embeddings. Let's print the length, how many embedding it has created, and let's print one of the embedding just to see everything works fine. Perfect. So it has created 41 chunks. For all of them, it has created this embedding, and that's how we are inching very close to creating rack. And in the next lecture, we are going to finally create a vector database using Postgres. We'll host the vector database locally with the help of Docker. Then whatever we have learned till now, that is loading document, creating chunks, creating embedding, we are going to index those documents into the vector database. Then we'll use them for our LLM to make an informed decision. So thank you for following this session. Thank you. Now we are going to learn how can we make an actual rack system, defining the name as PG vector container, and I'm setting some of the environment variables like a default Postgres user and the default Postgres password as well. Let's make it password, and after that let's also set an environment for Postgres DB. Let's mark it as LC for now. This is going to be the database name. And now let's define the port mapping from 6042 to 55432. Now we can define the PG vector as the Postgres 16. Once this is done, it has created a container. We just need to start it. So once this much step is done, let's bring LangChain community and import text loader. So from LangChain OpenAI, let's import Azure Chat OpenAI and also the Azure AI embedding. For now, let's only focus on how we can make production ready embeddings. So in the LangChain text splitter, let's import recursive text character splitter, and from LangChain let's also bring Postgres for vector store, and let's import PG vector. So from LangChain community, let's first import documents, and then let's bring a UUID because we are going to give a unique ID. So now let's define our connection URI, which is going to be Postgres, and we will be pointing to our localhost server that we just now created. So you have to define like Postgres SQL plus PS copy and the database and the password. I have made it password, connected to the localhost. the port that we have defined, 6024, as you can see, and then go to the LC collection. So now let's do one thing. Let's load the raw document from text loader that we have learned about in the second episode of this series, and let's bring this document. Let me copy the relative path, and that's how it's done. So now we also need to specify just in case encoding, and once this is done, the text, we need to call the text splitter that is going to recursively create the chunks of this document. Let's define the chunk size of 1000, and let's also define a chunk overlap. Let's make it 200, and then what we are going to do is for these document, let's load them, text splitter dot split document, and from the raw documents now we are also need to bring the embedding model. Let's use ADA 002. Let's refer this model. So let's use same model. Let's also not forget to import load.env, so such that our credentials are being fetched properly. Now we need to define the pg vector from documents. So we need to define document and the embedding model. Let's also pass the connection URI. Let me handle it. So now we have the postcase connection class is available. Then we can do this similarity search. Let's define a query. Just let's run it and see if everything's working fine. Let me ask a question. What is LangChain? So now let's do uv run module 2 db, and let's see if our server is running. We can also check the logs as well. We can see it's running, and let's see, it will take some time because it's going to chunking. And so actually there is a problem with connection string. I have fixed that. Now let's see this, right? We have one more error. Let's add this dependency. Hopefully after that all errors will be gone. I am going to add those error parts in the video so that if you also face same errors, then you can just come to this section. So one thing to note, you'll need ps copy to be installed as a dependency additional to your LangChain. And so here you can see we were able to make the query, and it's returning as 4 document. So perfect. Now we were able to make the embedding and the connection. Now we need to learn how to add documents. Let's say during the runtime. Let's say when the chat is happening. If you wanted to add some embedding, so for that you need an unique UUID. So let's create UUID 4. It would be better. And once that is done, so we are creating 2 UUIDs just for test. Let's also add 2 documents corresponding to that, and let's add some page content. Let me write some quickly. This tutorial is written for LangChain, and let's also define a metadata. That's very important because it's the same way we have done recursively with the help of the pg vector dot format document. So let's maintain the consistency here as well, and let's copy paste it again, and there you can see. Now let's modify it a little bit, and let's write LangChain is awesome for making the AI development. All right, now let's move on to the next part. We need to define a IT. So let's provide the ID array that we have defined in line number 34, and let's see, let's do some formatting and let's see if this is successfully done or not. So let's also do one thing. As soon as we add them, let's also delete them with the help of those UUID, because that will be present in the session. So we can call db.delete IDs, then we can pass the ID array that we have defined. So this will ensure that this, the fundamentals you need to learn, like CRUD operations are important. We were able to do retrieve, but creation and deletion is also that much important. As an AI engineer, you should be well aware of that. So now let me add some debug this time. So hopefully everything works fine. It's going to do embedding again, and then it is going to add some document and then delete document. We should be able to see the logs as it when it happens. So yeah, document added, document deleted, perfect. That's all we wanted. And yeah, so this is what you need to understand. All right, everyone, let's learn how can we do the embedding management with the help of LangChain in our Postgres database. For that, let's import indexes, which is SQL record manager and index, and we'll also import our vector store from pgvector. After that, let's also import the LangChain OpenAI. From there, we'll import the OpenAI embedding, and let's also import LangChain doc store documents, import documents. So what we are going to do is, let's copy the connection string that we have created. In the previous lesson, we have created the vector database. So this is the connection URI. And now what we are going to do is to initialize a class with the help of this connection URI. So in pgvector, we need to pass the embedding model. So let's also collect it from the previous code. Let's pass it here. So let's pass embedding model as embedding model that we have initialized above. After that, we need to also give the collection name. So let's create a collection name. Let's initialize a constant collection, and let's call it YouTube Talks. Now, once we are done, now let's also create a namespace that will be helpful. Let me give it a name as YT namespace. Let's save it and then pass it. And we can also pass the connection URI, and we need to make it use JSONB as true. So by doing that, our vector store is initialized. Now we need to create a record manager. So from SQL record manager, let's give it a namespace. So namespace that we have defined. Let's give collection the DB URI as connection URI. And this is what we need. Now let's create the schema. This is going to initialize all of the required structure into our namespaces. From documentation, let's bring same documents that we did in the previous class. Let's add some documents. This is going to be the content. Now let's modify the metadata as IDs. Let's pass the IDs for now manually. And we can now define, let's say, a source, which could be, let's say, a db.py file where we are trying to retrieve this information. So let's do same thing here. And now let's also copy and let's give it some name. Usually when you are creating an embedding, there's already a tutorial present where you can learn how to do embedding from documents, multiple file types. So now let's initialize the index. Let's pass our vector store and we'll do a incremental cleanup. Now let's pass the source ID key as source. Now with that, we will be able to index those documentations. Now let me add a print statement to see if this is done correctly. Let's call our function. So uv run module 2 rack embedding management py. Here you can see we have added attempt 1, added 2 documents, and we were able to do a update. Now let's try to do second time, and this time you'll see what is the use of doing an incremental. So now if we run it, you'll see it got skipped because we have same document already present there. This is very much important if you want to keep your racks a clean one, because you don't want duplication to be there. So that's where the record manager will help. Now let's see if you intentionally want to modify some record, that is you want to do a mutation. Let's change the page content of our document 1. Let me type this is a new content that added in the doc 1, and let's try to do the mutation this time. And let's also copy paste the print statement, and this time let me comment out the previous code. So you see here what just happened. Now since we have changed the content, now it only skipped one, which was the one that was exactly same, and it deleted the index 2 and added a new in replacement of that. So this is important thing to learn, and in the next tutorial we are going to sum up everything that we have learned and build an actual rack system. Thank you very much. All right everyone, finally we are going to conclude this series as we are going to build a rack system. So we have been able to learn a lot of things, specifically in focus to create a rack system with the help of LangChain, and now we are going to bring all of the things back here, because we are going to bring the Azure Chat OpenAI model, the embedding, the databases that we have created, the text splitting using an actual document. So for all of these things I am going to do an import quickly for you, and as you can see, let's import LangChain core. Let's import prompts, let's import chat template, chat message prompt template, and we'll also need some other things from LangChain, that is the runnables. So we need chains, because I'm going to show you how can you make a chain execution of rack, which is very an interesting way of calling your rack system that makes your code really clean when you are building things in production systems. So here what I've done, I have bring all of the embedding model, text splitting documents the way we were doing in the episode 1. Feel free to check it out, and from there what we are going to do, we are going to create databases, and we'll need to pass our embedding models. After that, what we are going to do is to bring the collection. So the connection URI we have provided in line number 11. Let's call our retriever. So we'll call database as retriever, and then we are going to set the quarks. Let me search the documentation. It's written there. Yeah, this is the search quarks, and there we can specify the k value, that is the number of similar document that we are going to retrieve. And then let's call query what is LangChain, and what will happen, this retriever is going to invoke this query. Let's call it, and then we can see the documentations. So this is not how you are going to do an actual. The proper way of doing is through calling a chain decorator. But for now, let's see if everything's works fine. And so let's create a chat prompt template, and there we are going to give this retrieve doc as the context. Let me write a simple prompt for our model. So answer this question only with the following context, and we are going to pass the context, the question. Now let's invoke our LLM. Let's use GPT-5 mini. And we'll set the temperature to 0. So LLM chain, first LLM, prompt, then LLM, and let's see, this is going to be our LLM chain, and we can call dot invoke, and then here we can pass a dictionary of context in the question. So for context, let's pass the doc that we have retrieved from our retriever, and our question. So let's pass the query. Now let's see what has been returned. So this is how usually it goes. First retrieve document, pass it in the context, and then ask your LLM to generate response. Let's run it. It will take some time because it is creating an embedding, saving them into database. For the first time it will take some time. Meanwhile, make sure to check the other videos where we have learned all of the concepts that we have developed so far. So here you can see we got the context, and this is what we have saved in the documentation. That's why it is returning from there. This is awesome. Now we are going to learn a better way of doing this thing, which is, let's use the chain decorator. Let's add the chain, let's define its QA agent, and we'll pass our input query, and here we are going to call the retriever as invoke, and we'll pass the input, and then we'll format our prompt dot format prompt dot invoke, and then pass the same dictionary. So the context as the docs, we need to pass this in the dictionary, and then also the question, which is our input. Now let's format it, let's invoke it. Let me call the LLM dot invoke, and then we can pass the formatted one. Let me see if everything is fine here. Let's actually we need to call the LLM chain because it has the prompt and LLM. Let's see. Let's just run it and see if everything's work fine. Let's call our let's collect the response of QA, invoke, and let's pass the query. Let's see the context directly. Let's run module 2 rack, basic rack, and hopefully there is no error. I feel there's something missing here, but that's not an issue. Let me re-verify it. We are LangChain, and I think we should call the LangChain because no, actually we have to call an LLM as the formatting we are calling on line number 56. Sorry if I'm creating confusion, but I think that's the way. Yeah, let's see. Yeah, it throws an error. So yeah, it's happening because we need to call the LLM here. Then everything it was correct on the first time itself. Let's run it and see if it works. It's taking some time. That's okay. Meanwhile, let's sum up things that we have learned. This series was basically in focus of learning the rare concepts that usually you won't find on any YouTube tutorial because people do skip those concepts. They are indeed very much required. And then now we are going to move on to LangChain graphs or LangGraph, and we are going to deep dive into agents and all. So there you go, we have our output, which is pretty awesome. This is what we wanted. Thank you, really thank you very much for watching this series. I hope you enjoyed it. Thanks.